In this video, I'm going to show you how you can deal with straight lines when it comes to polar coordinates. So here you've got a straight line here. We're going to deal with this straight line because when working in polar coordinates, we've got to move to the straight line. Well, let's start again here. We've got a surface and we want to integrate it from y equals 0 to y equals that straight line. So y equals 0 to the straight line, y equals 0 to this straight line, y equals 0, and scan it from x equals 0 to x equals 3. X equals 0 is here, x equals 3 is here. Scan it all the way through. So you're actually doing this. So the region we're talking about is this region here. So to convert it into polar form, well, this thing will be replaced with this thing here. And x squared plus y squared, we can replace that with r squared. And in polar form, remember, in polar form, you're moving around like this. You're moving around like this. You're moving around like this. So the angle is scanning all the way through. But the thing is, you've got to move to the straight line. See this straight line here? You've got to think. You've got to think how to express that in polar form, because you're scanning all the way like this, and then you stop at an angle of this angle here, theta here. You've got to stop at this angle. So let's start again here. Remember, in polar form, you're scanning like this. You're scanning like this. So you've got to jump to the straight line from r equals 0 to the vertical line. R equals 0 to the vertical line. R equals 0 to the vertical line. The hard part is in coming up with the expression for this vertical line in polar form. So we've got to come up with the radius, because we want to know the radius, because we're scanning from 0 to the vertical line. So you want to know the radius for any given angle. Let's say this angle here, you have to come up with the radius. For this angle here, you have to come up with the radius. For this angle here, you have to come up with the radius. So let's just say currently our angle is theta. We want to work out the radius. So really, we've got this thing here where the angle, for any given angle, we have to know the radius. This length is always 3. So we want to know r here. So in polar form, hang on, this would be cos. So cos the angle equals 3 over r. We want to know the radius each step of the way. As theta changes, we want to know the radius. So make r the subject. So r equals 3 over cos theta. So you can imagine this as being 3 times 1 over cos theta. So this is just secant. So the way to express this radius is really 3 secant theta. So for any given angle, we can work out the radius, and it's given by this. So wait there. So as the angle increases, the radius is given by 3 secant theta. So here you're scanning from from a radius of 0 to a radius of 3 secant theta, and the angle you're scanning like this, and you stop at this angle here. You stop at this angle here. Well, this angle here is inverse tan 4 over 3. So you, 0 to inverse tan 4 over 3, and radius is from 0 to 3 secant theta. So really the volume is given by this whole thing here. Merge these two together, and it will give you r to the power of 3. It will give you this. So we are currently at this step here. So now let's try and integrate it. So when you integrate r to the power of 3, it will then give you this. And we're integrating from the radius of 0 to radius 3 secant. Radius of 0 to 3 secant. And then now we can put this into here. So that will then give us this thing here. And then when you put 0 into here, the whole thing is 0. So that will then take us to here. So now now this thing here is just a constant. So let's move it out here. So that will then give us this. And then imagine secant to the power of 4. Imagine secant to the power of 4 as one block multiplying another block. And this block here, we can convert it to this. So you should know by now that secant squared is the same as this thing here. So we can convert this block to this block here. And then multiply this out. So this times this will give us secant squared. This times this will then give us this. And notice that this is a derivative of tan theta. So you know this is going to be easy to integrate. Or integrate this, it would be this thing here. Integrate this, it would just be tan theta. And we're integrating from 0 to inverse tan 4 over 3. From 0 to inverse tan 4 over 3. And then when you put this whole thing here into the angle, just into the angle, it will give you tan. It will give you tan. And then when you put this into here, it's this thing here. So you can see that when you tan and inverse tan, it's just going to leave you with 4 over 3. And the same goes over here. When you put this into here, it will be this thing here cubed. Remember, you've got to cube it first, and then times by a third, and then times by a third. So that will then take you to here. So now if you tidy this whole thing up, it will give you a volume of 43. So the answer is 43. Okay.